Got it. Well, thank you for the invitation. Let me just hit that. Hopefully you can all hear me now. I'm not muted. It's been fun listening to you folks. I grew up as a birder in north of Philadelphia in Montgomery County and Bucks County. And a lot of the birding places you've been talking about are actually quite familiar. So it's sort of nice to be back home. I spent a lot of time at Forsyth, South Jersey, birding as a kid, both junior high school and high school. Wyncote Bird Club, which is now Wyncote Audubon, was one of the organizations I was very active in. So, I'm very partial to birding groups, and I did get out Global Big Day on Saturday. Our group, which had members several different continents, we came up with a species list of about 450 species. So we did fairly well. And we did as a fundraiser for Birds Caribbean, the organization that I'm with now. Anyway, to get to my talk, we'll start with these pictures, which all of you have noted. These pictures to me are quite shocking because this change that you see here can happen in a few hours. Imagine fall coming in Pennsylvania in one day. It's a shock. I mean, yeah, we're all used to leafless trees and deciduous forests in the winter months, but they lose their leaves relatively slowly as we go into as we go from fall to winter. But this is just a shock, and this is what the forest where I worked in eastern Puerto Rico and Junque National Forest looked like before Hurricane Hugo, the center slide, and a couple of days afterwards when we could get in and the roads were opened up, this is what the forest looked like. So it was a closed canopy forest like this, and afterwards like this. And if that's not shocking enough, this is more recent example. This is after hurricanes Irma and Maria, which hit Puerto Rico in 2017. And this is what this site with the waterfall here looked like before the hurricane. This is what it looked like shortly afterwards. And this picture over here shows the entrance of the forest. And you can see it's a stark difference. It's quite shocking. I've been through a lot of hurricanes personally, and I've done a lot of studies on them. In most cases, it's all been by accident. I just happened to have what we call baseline. That is, we had some data beforehand. In other words, we knew what the bird populations were like beforehand. We even had some vegetation measurements. And after these storms, we were able to get back and resample them. So my talk tonight's going to focus on those types of studies that I've done over these years. This is the sort of thing that I have focused on. So let's take a look. Now, the obvious things that you all know, of course, is that hurricanes can have both direct and indirect effects. And the direct effects, as I said, are the ones that are fairly obvious. There is direct mortality from exposure to winds, rain, and flooding. There are pictures here of a cattle egret killed probably by high winds. These flamingos, this is a photograph taken in Cuba after Hurricane Irma in 2017. This is a group of flamingos that succumbed to direct effects of that storm. And this tropic bird, which is a pelagic species in the tropics and washed up ashore in Puerto Rico after the hurricane. So there is direct mortality. There's also geographic displacement by winds, and I think most of you are familiar with it. We like to get out in the field after hurricanes if we're inland looking for frigate birds or pelagic species that are blown inland, and this is not an unusual occurrence. So these are the direct effects, but it's these indirect effects that can have the longest lasting effects on the bird populations and add complexity to our understanding of what's happening. These indirect effects can include the loss of food supplies and foraging substrates. They can also result in changes in habitat structure and composition. Imagine, if you will, a closed canopy forest before a hurricane, and then after the hurricane, with tree falls, creates gaps in the forest. So the structure, as we call it, of the forest has changed. And this can, of course, affect bird populations. There are also changes in vulnerability to predators, competitors, and parasites. Often many of these predators are able to survive the storm and then are able to prey on birds that no longer have cover to hide themselves. So these can add to the stresses. Also, the loss of nests or roost sites are quite common. Large nests, like raptor nests in large trees, can come down. And this could be quite problematic for species that invest a lot in their nests. Now, before I start talking about details, what I'd like to do is just show you overall diagram here of some general effects of hurricanes. And I'm going to walk you through this diagram. And I do apologize for showing you some graphs at this time in the evening. However, it's really the only way we can picture some of these responses. And this is a graph showing the change in magnitude. That is the change in a state or a change in a population before and after a hurricane. And we graphed it here against time after the arrival of hurricane. And the graph here shows a number of different trajectories or responses of populations or of ecosystems. And this is the work of Jess Zimmerman, who has worked with others in the Luquillo Mountains in eastern Puerto Rico, and they've done several hurricane studies. And these show some of the patterns of response for 5 years after Hurricane Hugo. As I mentioned, this is a change in magnitude. Populations can show sudden increases, often such as graph A here. They'll increase from the baseline, that is the population level before the storm. They'll shoot up and they'll come down very quickly. Some insect populations do that. This also can be a measure of ecosystem components, such as dead leaves. Imagine after a hurricane, all of those leaves, of course, going onto the ground, or all the dead wood on the ground. You get this pulse of resources, and that pulse of resources is often a food supply for some sort of organism. You can also have increases, as shown in B here, that are a little more gradual, and then they slowly come down to the baseline. In this case, 4 or 5 years after the storm. And these are the patterns found in some of the shrimp populations in the streams, as well as in some of the frog species, such as our coqui, which is a type of tree frog, genus Eleutherodactylus. And these frogs actually benefit initially from these storms because they breed on land, very different than our temperate zone species with tadpoles. In ponds or streams, the tadpole stage actually occurs on land. The female lays her eggs in an area that's protected. They'll take advantage of a lot of the down timber and branches. She'll lay her eggs there. A male will immediately fertilize those eggs and then guard the eggs until they hatch and will stay there. Well, anyway, the downed timber and branches provide hiding places for these nests of the coquis, so their populations do increase. Other populations may not show a change. They may be consistent through the baseline, although that's pretty rare. And then the other response, of course, are the declines, which you would expect. These can be catastrophic declines, they can be gradual declines, and they can show levels of recovery, as we show here, such as in C, it shows a catastrophic decline and then an increase that overshoots the baseline. And this is what's been found in populations of, for example, snails. Snails do quite well some species, not all, after these storms, and they will recover quite nicely and actually for a short period after the hurricane have higher populations before. This was also found in the Jamaican fruit bat, Artebius jamacensis. This is a bat that, as the name suggests, feeds primarily on fruit, and they show a catastrophic decline. But as the plants recover and begin to produce new fruits, these fruit bats can do quite well. Other species of bats, like this one shown here, Stenoderma rufum, takes longer to recover. It's not as mobile, that is, it doesn't have large home ranges, so it tends to stay around home, so it takes a little longer for it to for its populations to recover. You can also have a slower recovery, such as shown here in E. E represents a tailless whip scorpion. These are arachnids. They're related to the spiders, and they feed on things like cockroaches, and their populations can get knocked back. I would point out that these tailless whips scorpions also prey heavily on the eggs of the coquilles. So depressing these predator populations are advantageous for these coquilles. And finally, the walking sticks. This is one of the large species we have in the rainforest there, and their populations were knocked back, and at the end of the 5-year period of this study, they still had not recovered. So this shows some of the diverse responses of organisms. Now, I show no birds here because Zimmerman and his co-authors didn't have any bird examples when they put the graph together. But I think these patterns are important to understand because these many of these organisms shown here represent the prey items for birds or represent predators of the birds. Now let's move on to the next. Now let's take a look at this graph. And what we're going to do is define resistance. Same type of graph or figure you saw before. I've graphed here the change in magnitude against time after a hurricane. The line here shows the baseline. The shaded area here represents about 15% above the baseline or 15% below. In other words, it's a measure of variation. Hurricane can hit at time 0. Population will show a small decrease in the magnitude and then return fairly quickly. So we say that this is a species that is for a population that's highly resistant, whereas population B and C are displaced considerably below the baseline. These are species or populations that show less resistance to these hurricanes. The plants, of course, can show resistance. And the way to think about resistance is to think about people. If you live in a rock or a concrete home in a hurricane zone, you're going to have a house that is much more resistant than a house that's made out of wood or a grass shack. So that's the concept of resistance. The vegetation will show resistance in terms of survival. Palms in particular are remarkably resistant, even though it looks as though they're just going to all die off immediately after the storm. These are some photos in Puerto Rico after different hurricanes showing the palm forests or the palms that are still standing upright after the hurricane. You'll see most of them have lost their palm fronds, at least for the Sierra palm. Royal palms lose a lot of their fronds, and the coconut palms in this example, most of them have lost their fronds. But despite losing them, they managed to recover quite quickly and reproduce or sprout the palm fronds, and there's relatively little mortality of these palms, which is a good thing because a number of these species, especially the Sierra palm, are very important food sources. That is, their fruits are important food sources for a number of bird populations. So we speak of these palms as showing very high resistance to the storm, and we're talking about the resistance in terms of mortality. If we're talking about the palm fronds flying off, well, they're not very resistant. They, of course, blow off. So you have to be specific as to what you're talking about when you mention the term resistance. Another term we use is resilience. That is the recovery time after a hurricane. This is a similar type of graph showing the response trajectories of 4 actually populations in time, and showing our baseline here, the arrival of a hurricane, the decline of population A, but it recovers very quickly, whereas populations B and C, B a little faster in recovery time, and then finally C, whereas population D shows no recovery, at least in this time period of our study. So we say here that the resilience of A is greater than B, which is greater than C. I'll give you an example of a very resilient plant population, and this is of importance to birds, are populations that are in the lowlands of these islands. This case, this is an example after Hurricane Gilbert in the island of Jamaica 4 months afterwards. And here you can see vine growth over a fallen tree that came down after the hurricane. You can see leaves have been produced on these trees. They had been stripped off after the hurricane, but in 4 months, recovery was well underway. So this is a very resilient habitat. Whereas if we go up into the mountains of Jamaica, which we did after Hurricane Gilbert, we discovered that none of the plants had shown any sign of recovery 4 months after the storm, despite what we saw in the lowlands. So these upland or high elevation sites show relatively low resilience. And this is not surprising because plants grow much more slowly at high elevation or cooler temperatures, and often the soils are waterlogged, and that of course slows growth. But this has importance for the bird populations, as you'll see in our next slide. And we'll relate the bird populations now to these resilient or habitats, either low resilience in the high elevation or high resilience in the lowlands. I mentioned that we studied the effect of Hurricane Gilbert, which was a class 3 storm that hit Jamaica, and it spent about a day over the island and went the full length from east to west. It was a devastating storm. The Jamaicans suffered greatly. There were at least 45 mortalities, $2-3 billion in damages, and took quite a while for the country to recover. We had baseline studies underway when this hurricane went through. We had done surveys of bird populations throughout the island of Jamaica prior to the arrival of the storm. We were able to return 4 months after the passage of Gilbert and resample all of those locations. The results I show here I'll compare before with after. Let me walk you through this. These are the results of our surveys in the montane habitats. The surveys are conducted using a method which we call point counts. Point count is, as the name suggests, a single location where an observer stands for a 10-minute period and counts all the birds detected within 25 meters. After that 10-minute period, we then hike off at least 100 meters, and we replicate that 10-minute period of observation or listening for the birds. And we record all the birds detected, as I said, within 25 meters. Okay, so that's the basis here. And what we did for our analysis, as I show here, is we tally each bird species population as to whether it shows a decrease or an increase or no change. So we go into a habitat, such as this cloud forest, as you can see here on the left. We run these point counts, usually 30 point counts per habitat, and then we tally the direction of population change for each bird species in this count. So as you see here, we have more decreasing populations at high elevation than populations that show an increase or no change. In contrast to the lowlands, that is below 900 meters, we see that there's very little difference in the numbers of populations showing decreases. In this case, 100 species populations show decreases. In contrast to the populations that showed increases or no change, in this case, 110. So the difference here is that should jump out at you is there are more decreasing populations at the high elevations than there are in the lowland habitats. And this appears to be closely related with the resilience of these lowland habitats versus the highland habitats. Remember, we saw no evidence for recovery here in the vegetation whatsoever at high elevation, in contrast to the lowlands, where even after 4 months after the passage of this storm, there still was evidence for recovery beginning and actually moving well along. Well, let's take a look at the bird species that showed changes in these montane habitats. To do that, we classified the birds based on their diets, and we were able to do this based on previous studies done in Jamaica. The avifauna in Jamaica is quite well known. So we went to the literature and we classified birds into several categories that should be fairly obvious here. Nectivores, of course, birds like hummingbirds feeding on nectar from flowers, frugivore seed eaters, and then we took the insectivores and divided them into two categories. The resident insectivores, that is the Jamaican species that are there 12 months of the year and breed there in Jamaica. And then the migrant insectivores, primarily species of birds from North America that overwinter in Jamaica, and actually primarily warblers. So we split these two groups for our analysis here. Same type of tallying of data as I showed before. We tallied the number of nectivore populations that showed decreases in the highlands versus showing no increase or change. So you see 8 decreasing populations versus 2 that showed an increase or no change. The frugivores, quite a marked change here. 19 populations showed decreases versus 4 populations that showed increase or no change. So quite marked differences here when you compare them with the insectivores. The resident insectivores, we found no differences in those two categories of decrease versus increase or no change. And even the migrant insectivores, very little difference. 10 showed decreases versus 13 that showed increases or no change. So the obvious pattern here, as you see, is that those that depend on flowers or fruits or seeds are more likely to decline after these storms than are the insectivorous species. The fact that we see a pattern such as this, that is a diet response to hurricanes in the terrestrial birds, suggests to us that the strongest effect of these hurricanes, terrestrial bird populations, is not the actual hurricane itself, but in the aftermath when food supplies may be limited for certain species. And we see that in the pattern, of course, of insectivores versus the nectivores and frugivores. But it's worth comparing these two groups of insectivores. The resident Jamaican insectivores were present when Hurricane Gilbert went over the island, whereas the migrants, North American migrants, most had not arrived when Gilbert went through the island. Gilbert was a September storm. Most of our migrants in the Caribbean don't really arrive in any numbers until about October. Yeah, there's a few ovenbirds and water thrushes coming in early the end of September, but by and large, the great bulk of them come through a little later. So here are two groups, one group that went through the hurricane versus another group that didn't, and there's virtually no difference between them. So the diet pattern has now been shown for a number of hurricane studies. This is quite a common thing. Now, let's take a look at some of the species involved. These are examples of species which declined in Jamaica after Hurricane Gilbert. For example, the orange quit, related to the tanagers, is highly frugivorous. They showed major declines in montane pine plantations and also montane coffee plantations. The black-faced grassquit, which is a widespread Caribbean species, did not decline in the upland areas, but did show, interestingly enough, a decline in the dry limestone scrub. Yellow-shouldered grassquit, an endemic species in Jamaica, showed declines in montane cloud forest, coffee, and pine plantations. The black and white warbler, which you all know, showed declines in montane pine plantation and lowland shade coffee. And as you also know, the black and white warbler is primarily insectivorous. They'll take some spiders, but primarily arthropod or invertebrate prey. We pointed out a pattern where the insectivores seem to do well. What happened to these black and white warblers? Well, quite simply, they lost their foraging substrate. As you know, black and white warblers forage out on the ends of branches. The branches were eliminated when the pine plantations were decimated. All the pine trees came down. The birds had no place to forage. In the lowland shade coffee plantations, the shade overstory, which protects the coffee trees from the direct sunlight, was destroyed by these storms, and it was in the shade canopy where the black and white warblers forage. So they disappeared from those habitats, presumably moved into other habitats. But the point here is they lost their foraging substrate. And finally, the hummingbirds, the streamer-tailed hummingbird, which is the national bird of Jamaica, showed declines in all of the high elevation or montane habitats that we sampled. So these are examples of the birds that declined in Jamaica. But back to the question about the insectivores. Why do they rarely show declines? Why are they so relatively resistant? Well, a number of reasons for this. First is just the nature of the life cycle of insects. It's a rather short life cycle for most species, going from an egg, larvae, pupa, adult stage, or various instars, but it's relatively quick. So it's possible that when these storms go through, they might lose a stage. For example, the adults might be killed on the leaf surfaces, but the larvae in the ground or in the wood may very well survive, and it doesn't take long to recuperate. The other fact is that there are resources available immediately after the hurricane or shortly after for these insects. Think of that slide where I showed and talked about all those leaves and dead wood on the ground. Well, that's food for what we call detritivores, insects or organisms that feed on dead plant material. Their populations increase, which shouldn't be surprising given all the food available to them. And herbivorous insects, the foliovores, those that feed on foliage, also increase. They increase because the leaves, particularly in the lowlands, as they come out quickly, they begin to produce new leaves. New leaves tend to have fewer toxins than the older leaves and are more likely to hit by populations of caterpillars, or in this case, as shown here, by various beetle species. So there are outbreaks of these herbivorous insects, and birds such as this logger-headed kingbird are able to take advantage of these outbreaks. So a real advantage here for the insectivores. but not so for those that feed on resources produced by plants or directly produced, that is flowers and fruit. This is a histogram showing what happens to uh, plants that are bearing flowers and fruit when these storms come through. These are data taken from a study we did in Puerto Rico, mid-elevation cloud forest, where we were studying 100 uh, plants, primarily trees, although a few vines, that were producing fruits and flowers. We were monitoring the timing of production. This is important for the frugivorous birds, such as the endangered Puerto Rican parrot. And we had 2 years of baseline. We would go out every month and we would walk a standard trail and sample each of these trees and determine whether they had flowers, unripe fruit, or ripe fruit. And as I said, we did this monthly, and we had 2 years of baseline, that is non-hurricane data, before the arrival of Hurricane Hugo, which came in October of 1989. So 2 years of baseline, and then immediately we were able to crawl out there. Really, it was a rather challenge to get in there, but we managed to do it. And we sampled those trees. We were able to find those trees and vines and sample the percentage of tagged plants that had flowers. And here you can see the levels before the hurricane. Here you can see the decline afterwards in the percentage of trees and vines bearing flowers. Similarly, relatively high percentage had unripe fruit before the hurricane came in, a decline afterwards. And ripe fruit, such as the Sierra palm fruit, as shown in this diagram, lower left here, yeah, fair number of the palm trees had fruit when this before the hurricane came in, and then that October afterwards, we see a decline. So basically, these resources are lost from the trees. And the birds, of course, can react to these losses by moving. And one of the things that the hummingbirds will do is they'll actually go down to the ground and try and feed on flowers that have fallen to the ground. And this is a rather sad photo of an Antillean crested hummingbird. This is a photo taken on the island of St. Martin in 2017 after Hurricane Maria devastated that island. And this is a crested hummingbird female trying to probe not an actual flower, but a colored paper that's down on the ground. So it was in search of food. Now, I might point out to you that they did put in a rescue effort and put up hummingbird feeders immediately or shortly after the storm. So they did try and reduce some of this potential mortality. But I mentioned birds will shift or change their locations. Not surprising, of course, they fly well. And if there's no food, well, they move. And we have good evidence for that. And the scales or the distances at which they move is quite variable. Now, there are accounts, observations from going even back to the 1700s of pigeons leaving islands after the passage of a storm when presumably there was no fruit available. So we do have some evidence that some birds will actually just leave an island. But in most cases, that type of movement is not real common. But we do have some evidence that the highland or the montane dwelling species, such as this bananaquit, which if you've been in the Caribbean, many of you may know this bird, it's ubiquitous, with the exception of Cuba, but that's another discussion. It's a nectivore, frugivore, and in our Jamaica studies, they showed declines, percentage declines shown here, in montane pine plantations, montane coffee plantations, and they showed increases in populations after the storm in wet limestone forest and dry limestone forest. Okay, so these are 4 months after the storm. This evidence showing decreases in the high elevation and increases in the lowlands is consistent with an elevational or altitudinal migration. And we have evidence that other birds will do that. We also know that canopy dwellers will shift to ground level. And we discovered that it was quite surprising in Puerto Rico after Hurricane Hugo went through. And one of the canopy dwellers that we encountered in great numbers in our mist net captures were the Puerto Rican toady, as shown here. It's an endemic species. The toadies, as some of you may know, are the family is endemic to the Greater Antilles. Um, and they are insectivores, but they do feed in the foliage. They feed by flying up to the undersurface of leaves and grabbing insects off the surface of the leaves or spiders. And what we found in Puerto Rico, we were quite surprised that these toadies were primarily at ground level after the passage of the storm. And the way we documented it was that time I got some baseline, a year's worth of data, sampling every 2 or 3 weeks with my students from the University of Puerto Rico. We had done a study looking at bird distribution in the forest, and we used mist nets, which I think many of you are familiar with, very fine nets that are strung between poles. They're called mist because they're like a mist. They're very difficult to see. Birds don't see them, at least in the shade. They fall into them, and you can remove the birds safely and then take your measurements and ban them and release them. So we did a study before this hurricane. And then once Hugo went through, we were able to get our nets back in the same locations within 2 weeks of the passage of the storm. And our first netting session, which the results are shown here, we were shocked to find that we had many more bird captures than we ever had before. Uh, we weren't expecting this because the forest had been nuked. There wasn't a green leaf to be found. And we just thought it was a total devastation to the bird populations. But contrary to expectations, we put those nets up and we were overwhelmed by the captures of birds. But when we looked at the captures and broke them into categories as to where they forage, as shown in this example, we broke it down for the canopy dwellers, those that are up in the tops of the trees, those versus those that are either on the ground or at least within maybe a meter or so of the ground. And what we saw in the results, as you see here, when we compare the captures per net hour, which is a way of standardizing the captures. We compare before with after, we see that we have about 3 times as many captures of canopy dwellers after the hurricane than we had before. All right, so more canopy dwellers, such as this Puerto Rican toady. I know we had other species of canopy dwellers also, but my point is the canopy dwellers were now down at ground level. These mist nets, if you've seen them, you'll realize that they really are not much taller when they're strung between poles on the ground, usually not much taller than maybe 2.5 meters tall. The understory dwellers, interestingly enough, showed no changes in the capture rates. Even though the canopy had taken off, they still were there, and the numbers were, excuse me, very, very similar. So the take-home message here, canopy dwellers simply follow the canopy down to ground level. Now, after a few months, they dispersed and they moved to other locations. But immediately after the storm, we found these patterns. So birds will, in fact, shift locations. Well, not all declines are simply a result of shifting locations. And sadly, for the Puerto Rican parrot, uh, uh, it looks as though the declines are directly related to mortality, not necessarily direct effects of a hurricane, but nonetheless, case of mortality after the storm. The Puerto Rican parrot is an endemic species. It is one of the most endangered species in the world. The population was down to 13 individuals back in the 1970s, but they've been able, with very intensive management efforts, to bring the populations up. We now have 2 populations in Puerto Rico, Loquillo Mountains here in the east. This is where El Junque is. And then in north central Puerto Rico, the Rio Bajo State forests. So two populations here, Hurricane Maria, which arrived in 2017. It arrived as a class 5 hurricane. It was terribly devastating to the island and the people of Puerto Rico, as well as the vegetation and the infrastructure. It arrived as a class 5 storm. It slowed down a bit. As it entered Puerto Rico, it entered as a high class 4 storm and passed across the island in this direction, wreaking havoc on the poor island. The bird populations suffered, particularly the parrots. Those in the Luquillo Mountains showed a decline of 96% of parrots prior to the arrival of this hurricane. There were 53 to 56 birds in the wild. Afterwards, there were just 2. In Rio Bajo, which was also hit by this storm, and at least the vegetation just as devastating, the population decline was only about 45%. And I say only 45% when you contrast that with the 96 in the Luquillo Mountains. This is nowhere near as severe. There were about 130 to 136 birds before the arrival of the storm. Afterwards, about 70 to 80. We attribute a lot of the survival of these birds after the hurricane to the fact that in Rio Bajo, they actually fed the parrots. The parrots knew where the feeders were. When they established the population in Rio Bajo, or I should say reestablished it, they release birds at their aviary. There's an aviary at Rio Bajo, and they released the birds into the wild, but they also fed the birds native fruits so that the birds could adjust to foraging on natural fruits. This was not the story in the Luquillo Mountains. There was no feeding program afterwards. There didn't seem to be any way to attract the birds to feeders. They wandered widely. Some of the individuals were seen. So it does seem as though this feeding played a role in the survival. Well, let's take a look at these parrots as an example of resistance. And this is the diagrams you saw earlier where I showed the change in magnitude. And I've spoken and given you examples of the Puerto Rican parrots in the 2 locations. The population declined. As I mentioned to you, I also want to point out to you that parrots did survive that storm. Not all of them. There was evidence for direct mortality, that is, the storm killed birds outright. But there still were flocks, for example, in the Luquillo Mountains, of as many as 11 birds seen after the hurricane, suggesting that a fair number actually survived the direct impact. However, afterwards, when there was no food and no cover, they likely had to move and forage more widely and were likely prey to red-tailed hawks. There's a high population of red-tailed hawks in the Luquillo Mountains, and they are a major predator on the parrots. Now, my experience with red-tailed hawks up here, and certainly in Pennsylvania, is that they were sort of marginal bird predators. But in Puerto Rico, this is a resident population, they do feed on birds, and they do feed regularly on the parrots. So you can imagine a slow-moving parrot in search of food and having no cover. It would be an ideal prey item for the hawks. So it can be a serious issue here, and we think that contributed to this decline. Contrast this with the Hispaniolan parrot, and I'm citing a very interesting study here, remarkable study, really. This was a study done by Jaime Collazo and his collaborators to understand the movements, the behavior of aviary-produced parrots released into the wild. And they did this to help devise or design release methods for the Puerto Rican parrot. So they went to the Dominican Republic and they went to the eastern end of the island, and they released 25 Hispaniolan parrots with radio transmitters. So they used radio telemetry to track or to follow these birds. And they had the birds released. The birds began feeding in the wild on native fruits, which they had trained them on in the aviary when they raised them. They had about 2 weeks of baseline data. All the parrots were doing fine. All 25 were alive. And then Hurricane Georges, a class 3 storm, had the misfortune of arriving in the eastern end of the Dominican Republic and went directly over their study site where they had been following these radio tag birds. Well, they assumed the worst. And the next morning they got up and their study site was leafless. The fruits had disappeared, but they went out with their radios and they were able to find 24 of the radio tag birds alive and moving around in search of food. One bird they couldn't find. It may have been killed or the radio may have fallen off. The fact is they don't know. But at worst case scenario, they lost one bird. All right, so this was a powerful storm and the direct mortality for these birds was relatively low. However, with time, the birds started moving more widely in search of fruit. As I mentioned, the fruit had disappeared, and then mortality began to increase over time. So this gives you an idea of what's going on, and it goes back to the idea that a lot of these birds can survive the direct impact. It's that aftermath when the food's gone and you're starving, and you have no, you know, protection or cover to hide from predators. And unfortunately, a lot of these predators, like red-tailed hawks, seem to survive these storms just fine. And we've done studies on the hawk populations, and they did not change after Hugo in Puerto Rico. So, well, now let's look at resilience differences, same type of graph again. Now we're looking at the recovery time. And we now know the recovery times of a number of species that have recovered from various hurricanes in the Caribbean, recent hurricanes. And we've found that these patterns of recovery, these are again, our sort of imaginary curves. We do know that there were declines in all of these populations, and we do know that things such as the endemic elfinwoods warbler of Puerto Rico, a high elevation species, a montane species, they recovered after 2 years versus the West Indian woodpecker, which in reality is a red-bellied woodpecker, very similar, closely related. Their populations recovered after a direct hit on the island of San Salvador in the Bahamas, but a relatively quick recovery to the baseline or prior population levels. The plain pigeon in Puerto Rico, their populations took 4 years to recover. And finally, the Bahamas parrot in the Bahamas, and in this case, the data come from the island of Abaco, Great Abaco. It took about 5 years for the parrots to return to their baseline levels. Now, notice the differences in the recovery times here. A lot of the factors involved are related to the reproductive rates of these birds. Take a parrot. The parrots have a clutch size of 2 to 3 eggs, and they only lay 1 clutch per breeding season. So at most, they're going to get out 3 young. The plain pigeon has a clutch size of only 1, which is unusual for pigeons and doves because most of them have a clutch size of 2. But the plain pigeon has only 1 egg. So you can imagine it's going to take them a while to recover. The woodpeckers, cavity nesters, they tend to have higher clutch sizes. They can have clutch sizes of 3 or 4 and will have multiple clutches in a year. For the elfinwoods warbler, clutch size of about 3, and they'll have multiple clutches in a breeding season. So the reproductive rates of these birds contribute to their differences in resilience. Now, it also helps to be in a resilient habitat. So if you're up in a high montane habitat, you're likely to suffer. Well, the elfinwoods warbler, and as you would likely guess, is highly insectivorous. can survive in those upland areas where a frugivore, seed eater, or an ectivore might in fact decline. So what can we do to prevent these storms from damaging bird populations? Well, one thing we can do is provide food during the post-hurricane food bottleneck. And we saw that in the parrots, the Puerto Rican parrots that I mentioned, where they actually fed them. As I said, the parrots knew where the food was. Everybody likes a free lunch, and they were quick to respond to that. So that played a role in the parrots. The Birds Caribbean, a regional group with which I'm involved now, had a program called Operation Feeder Rescue in 2017. They were able to ship to about 15 different islands after the passage of all those hurricanes in that year. They put out hummingbird feeders. They sent them to their collaborators and cooperators in all the different islands, and they got school children and families putting up hummingbird feeders, and they provided the shuttle necessary to put in those feeders. And folks did put up the feeders. And as you can see here with the swarms of bananaquits, this is St. Martin after one of those hurricanes. And this is another island with various hummingbirds, purple-throated carabier, so probably Eastern Caribbean somewhere. Coming into these feeders. So these did play a role. So you can try and feed birds after these storms. For species that are likely to lose their nesting sites, nesting cavities, it's possible to replace those cavities, and that has been done successfully with the Puerto Rican parrot. They are a cavity nester, as I mentioned, and they will take to artificial nest cavities if placed in the same area and if they imitate the real cavity. So after these hurricanes, the Forest Service as well as Fish and Wildlife Service have put up replacement cavities. Many of you may know the red-cockaded woodpecker in the southeast, species restricted to old growth longleaf pine. They are cavity nester. It takes them quite a while to build those cavities in the old trees. When these hurricanes come through, those trees snap, often sadly at the woodpecker cavity level and wipe out the cavities. So the managers have found ways to reproduce those artificial nest cavities, and the birds, the woodpeckers, will in fact use them. And in some extreme cases, it's possible to use a method which we call head starting. That is, we give the eggs and the chicks an increased chance of survival by collecting them from the nests and raising them in captivity. We do this to prevent risk from parasites and predators. And this is what was done for the Puerto Rican sharp-shinned hawk. This is a subspecies of sharp-shinned hawk, which is a endemic to Puerto Rico, endemic subspecies. And the population, although around 75 individuals, had dropped down to something like 17 birds after the passage of Irma and Maria in 2017. And the managers started a program where they would collect the eggs from the sharp-shinned hawk nests. That would cause the female sharp-shinned to relay another clutch of eggs, but the first clutch would go into an incubator where they were raised. Then they would raise the chick in captivity and then place them out in the wild using a technique known as hacking, very common among falconers, to release birds into the wild. Well, needless to say, this is a very intensive, labor-intensive, and expensive method. Can only be used for the most endangered species. But a lot of effort has gone into this method, and it has worked well for the thrasher. The other thing we can do is focus on the indirect effects. One is to protect resilient habitats as post-hurricane refugia. I mentioned that the resilience of these upland or high elevation habitats is relatively low. versus the lowlands. Many of the Eastern Caribbean islands have lost their lowland forests to agriculture and development, some tourism development and urbanization, depending on the island. And it's important to have fast growing, fast recovering vegetation and forest here in the lowlands if you want to save your montane species after these hurricanes. So there are some efforts to try and have reserves in the lowlands. I mentioned early in my talk that palm trees are particularly resilient, and although they lose their fruits and their fronds in the first year, the following year they do produce an abundance of fruit, which can help hold the frugivores over. So there are things that we can do to help them along. And finally, the biggest take-home message in all of this, which you've heard over and over, preserve habitat. The highest risk to these from these hurricanes to birds are in small habitat patches. So you want to have as many patches out there as available, and the larger the better. So that, folks, is the end of my story. And I thank you for your attention, and I'm willing to take any questions. Thank you.